All right, welcome to lesson 7.4, geometry notes, properties of special parallelograms. So we'll jump in here. We're basically extending our knowledge and what we learned in previous lessons about parallelograms to some very specific types of parallelograms. So let's do it. Let's jump in. Properties, all that stuff. So first one, these are all things that we've heard of, I'm assuming, before these particular notes. Rectangle, for example. Sure, we've seen that for years and years and years. But obviously, being a high school level geometry class here, we're gonna dive into a little bit more than just, well, what's a rectangle? Like what is that shape right there? Oh, it's a rectangle. Like what are some properties of it that we'll have to know? So rectangle, by definition, make sure we add this, a parallelogram, and that's why we're defining. Well, the reason we're defining everything as a parallelogram is we don't have to say all those same properties about parallelograms that we already learned in the previous lessons. We're saying, hey, this is a parallelogram, but now we're being a little bit more specific and saying, all right, it's got the 4 right angles. Okay, so let's see here. I mean, picture-wise, there's different things we could make. I know this is kind of small, but I think it'll work. Well, let's even back that up a little bit. If I, so I just got a 4-sided figure, quadrilateral, right? And if I want to make this a parallelogram, what's one way we could do it? Oh, opposite sides are congruent. It's got to be a parallelogram at this point. Okay. And then as soon as I add or see that, hey, it's got 4 right angles, now it can be a little bit more specific and say that is a parallelogram still, but we would classify that as now a rectangle. Okay. Yeah, so that's what we got. This is a way you could prove. So I know we did this in lesson 7.3 where, prove that without actually doing a prove that figure is a rectangle, or we did it with a parallelogram. So what's one way that you could show something? I got a figure right here, and right now it's nothing, but as soon as I see 4 right angles, I say, hey, that quadrilateral has got to be a rectangle. And you say, wait a minute, hold on, what are you talking about? What about square? We'll talk square down the road here, but it's kind of this, like, at minimum right now, this blue figure right here, I know this has to be a rectangle. Could it be a square? It could be, but I don't have enough information to say that at this point. I know for a fact it's a rectangle. Square is kind of like up for debate on something like that, okay? But that's basically what I need to see. If I see 4 right angles, I can be specific and say that's got to be a rectangle, okay? And then basically what we have left is property of. So one property that we need to know, just hold off on this here, but the diagonal, let's just say it like this, property of a rectangle is that the diagonals are congruent. All right, that has never come up for just any parallelogram. That's not true for just any old parallelogram. That's only true if we have a rectangle. So, yeah, let's just say, hey, let's just say we're told this is a rectangle. However we get that information. The reason I'm not putting the right angles on there is I don't want to make it too cluttered. But hey, we've got a rectangle. And then if I were to look closer at its diagonals, I would see, because it's still a parallelogram, they still cut each other in half. They bisect each other, but now the full distance, the length of each diagonal, like this diagonal right here, has got 2 tick marks on it. This one's got 2 tick marks, so they're both the exact same length. So we would say their diagonals are congruent. This is also another way to kind of prove that a quadrilateral is a rectangle. Okay, we need to kind of see 2 things. So if I see the diagonals are congruent, and then they also still bisect one another. So the bisect turns it into a parallelogram, and then the fact that they would be congruent would show that, hey, it's a rectangle. Okay, so we're getting 2 really things going on in this slide right here. The property of, if you have a rectangle, you know for a fact that the diagonals are congruent. But then, like, the second part would be, if I'm trying to prove a figure is a rectangle, I could look at its diagonals and see, do they bisect each other? Check. Yep, that's going on. Do I see that the diagonals are the exact same length? Check. Okay. So like head to head, if we compared it with, I give you a figure like this and say, is that a rectangle? And I don't know. At this point, I can't say for sure. If I get that piece of information, still, it's not even a parallelogram at that point. Now, if I get this, they're bisecting each other, but not congruent, that's just a parallelogram. Okay, but if I back up and say, hey, all right, let's take some of those tick marks off there. Whoops. Well, what I could do is just add and say they're still bisecting each other, but now they're congruent. That's got to be a rectangle. So that's kind of, we got to wrap our heads around that a little bit. I don't need to see a right angle symbol. I don't, here and here, all the way around, I don't need to see 4 right angles to say, oh, that's got to be a rectangle. That right there is enough to narrow this down and say that's got to be a rectangle. All right. I think that's it. You know what we'll do? We'll lay out all the notes here for the lesson. We'll get our other 2 figures. You can see what's coming. It's no secret. Rhombus and squares coming up. And then we'll look at a couple examples, and what I would ask you to maybe do with some of this information. Okay, so that's what we need to know about rectangle. What is it? And what are their properties, and how could I identify a figure as having to be a rectangle? So we'll follow that same pattern here for rhombus. So a rhombus is a parallelogram with 4 congruent sides. You'll also hear and see, you can refer to it as an equilateral, right? We know what that means. All sides are the same. Equilateral, quadrilateral is a way to say that. So picture-wise, I know there's not a ton of room. It's kind of like a rectangle. This is what you might think, or you've heard maybe in earlier grades. Whoops, it's not a great picture. I'm trying to make them all the same length as like a diamond. So whether my picture is great or not, I see these tick marks that are indicating that, yep, all 4 sides are congruent. We would classify that as a rhombus. Okay. Similar to the rectangle too, that's all I need to see to say that, hey, that quadrilateral has to be a rhombus if it's got 4 congruent sides. So very similar to what almost identical as far as the right angles. If I give you a picture that looks like this, you say, well, that's a square. Well, actually, right now, it's nothing. It's a quadrilateral. It's got 4 sides. That's about it. But then we get this information here, here, and here. And I say, without a doubt, that right there, it's equilateral. It's got to be a rhombus. You say, wait a minute, hold on. Can't that be a square? And that's not that's not really the question. It's like, could it be a square? Sure. We don't have enough information to say for sure it has to be a square. I have enough information to say this absolutely has to be a rhombus. We would need more to identify it as a square. Okay, so very similar to what we talked about with rectangle. Actually, 2 different properties here that we should be aware of, both involving the diagonals. Let's just look at them one at a time. So the property itself, we'll do kind of the same thing because there's ways to prove something's a rhombus by just looking at its diagonals. But the first property here is that the diagonals, if I know a figure is a rhombus. So if I'm told something's a rhombus, hey, that's a rhombus, or I know it's a rhombus, we would know for a fact that the diagonals would be perpendicular. So short and sweet. And again, that's never come up. That's not true for all parallelograms. That's not true for a rectangle. Right? Even if we just made a quick sketch of a rectangle and said, hey, are those, we didn't talk about that. Well, those don't look like right angles, and that would be the correct conclusion. That's not true for a rectangle. So this is a separate figure. First time this is showing up, diagonals are perpendicular. So picture-wise, I think going along with that, if I make my picture close to being equilateral as best I can, just freehand in here, it shows up a little bit better that, hey, yeah, those look like right angles. And again, if I want to turn this automatically into a rhombus, the quickest way would probably be to just say, hey, it's equilateral. All right. Yeah, so then right along with that, if I want to show, it's kind of that same idea of, is this a rhombus right now? No idea. Nope, absolutely not. It's a quadrilateral. But then we start getting some information on its diagonals. Well, still no information. I've just drawn them in there. We got to be careful here, because if I see this and only this, that's not quite enough to say, hey, you know what? That has to 100% be a rhombus. It's just not enough. There's other figures that happens with, and it doesn't narrow it down. But if I get this information about the diagonals at the same time being perpendicular, also bisecting each other like we see for all parallelograms, follow the logic here. The bisecting each other on the diagonals, that's what narrows it down to a parallelogram. And the fact that, all right, now we know it's a parallelogram, the fact that the diagonals are perpendicular as well, that's what narrows it down to rhombus. Okay, so we do need to see them both there, but that would be enough without any side markings as congruent. These diagonal markings is enough to say, yep, that's got to be a rhombus. Okay, second property here, we'll do the same thing. There's kind of the two parts to it. What is the property? If we know, let's see here. Let's do the picture first. If I know for a fact this is a rhombus, which that's the markings, that's all it takes is to say, yep, that's got to be a rhombus now. And I look at and I draw in the diagonals. We already know from the previous property that they should be perpendicular. So I'm not going to re-put that in there. But the property here is that the diagonals bisect each other. Yes, that's true. That's because it's a parallelogram, but they bisect both sets of opposite angles. What? And again, that's brand new, has never happened, at least as far as these quadrilaterals we've been talking about. So what does that mean? That each one of these angles, the big interior angles, so like that angle and this angle are getting cut in half, bisected, right? Cutting in half. And we know because we've defined a rhombus as a parallelogram that this angle and this angle should be the same. Opposite angles are congruent in a parallelogram. So when I cut each angle in half, I end up with I actually end up with 4 identical smaller angles. Same thing's true for the other set. You know, obviously we've got a parallelogram. So this big angle here and this bigger angle here are both the same. They're both congruent. So by cutting each one in half, now we got to be careful here a little bit. So I'm going to use a different set of markings. I'm going to use double arcs there. I don't know that all 8 of these smaller angles are the same, but I know I basically have 2 sets of 4 that are all the same. All right. So this one's actually enough to show that if I kind of follow that same logic here, what this is saying is that you've got a let's try to make it at least somewhat look like a rhombus. Well, you know what? Actually, let's do it like this. Let's make it look like a square. Say, all right, what is that? It's not a square. It's not a rhombus, not a rectangle, nothing. It's a quadrilateral. It's as specific as I can be, right? And we say, all right, let me give you some more information. Here's a diagonal. Here's a diagonal. So it's great. That's sweet. That's awesome. Still doesn't help me do anything. But then as I start adding information here saying, all right, how about this? That and that is true. I say, all right, I kind of like that. That's getting a little bit better. Still, I really can't say, though, parallelogram, rhombus, square, rectangle. And then I get that other set of, that congruent to that congruent to that. That right there is all I need to see to know that, hey, that figure that we're talking about right there, that's got to be a rhombus. Which is kind of cool. I don't know, like you don't have to know anything about the side lengths here. You don't have to know perpendicular. So how that works, though, is that, all right, now with this set of markings, that's enough for us to say that's got to be a rhombus. Now I know all that other stuff's true. Oh, yeah, that's got to be perpendicular. All 4 sides have to be congruent. But it was this set of diagonal or angle bisector markings that was like, hey, that's the trigger. That's enough to know that's got to be a rhombus. Okay, so that's still a part of what we're doing. Identify the figure based on markings, and that'll continue to be a part of what we do. All right, well, we're up to our last figure here, square. And this one you can see actually only gets 1 slide dedicated to it. So our square, still defining it as a parallelogram, so still carrying over all those properties of parallelograms. And I know we all know, hey, it's got 4 congruent sides, which was the property of a rhombus. And it's got 4 right angles, which was the kind of the defining property of a rectangle. So it's really putting together both our rhombus and rectangle into one single figure. So picture-wise, if I wanted to show that, I would show my rhombus properties right now. If I stopped, that's got to be a rhombus. But as soon as I add those right angles, that's when my rhombus becomes a square. That you could argue that's when your rectangle becomes a square, is when I have both of these going on. All right. So if I see that configuration, that's for sure that quadrilateral would have to be a square. There are other ways to see this, because basically, like I mentioned, we don't have any property side. I'm still going to put, though, properties of a square. And basically, it has every property of a parallelogram, rectangle, it says rectangle, and rhombus. Which is kind of nuts when you think about it. Like, all that stuff's going on. So you could make a really kind of crazy picture to try to show everything there. I think you probably lose some of that. So if I were to try to do that, let's see here. I'm going to try to make it big, so at least allow me to fit a little bit more in here. So let's see. What's the quickest way to make this a square? Probably mark it as equilateral. At this point, it's a rhombus. I throw my right angles in there. All right, now it's a square. And on the same picture, if I wanted to start illustrating, all right, let's throw the diagonals in here. And you're like, well, what? We didn't talk about the diagonals of a square. But I said, well, we talked about diagonals of a rectangle. Diagonals would have to be congruent. We've talked about diagonals of a parallelogram. Do they bisect each other still? Yep. The diagonals of a rhombus, what do? They're perpendicular, and they're angle bisectors. And this is unique in that now I actually do know all four angles are the same. So you get it looks a little different, right? All 1, 2, 3, 4, 5, 6, 7, 8 pairs or 8 angles, these smaller angles, actually would all be identical. And you could actually be specific and say 45 and 45, 45 and 45, 45 and 45. So that's going on. What's some other stuff? Sides, we would know some of our parallelogram properties, that opposite sides are parallel. Opposite sides congruent, opposite angles congruent, consecutive angles supplementary. So that I guess that does probably have everything on it there that we've talked about, but yeah, it loses it a little bit, or I don't know. They're just with everything going on there. Yeah, so that's what we need to know about square. It's basically got everything going on. We didn't really go over, what are ways to show something's a square. It kind of varies. Would take like that same approach as before, where it's, you get a quadrilateral. Right now it's a quadrilateral, and all right, well, let's see. Let's add some stuff here. Is that a square right now? No, it's nothing. Oh, okay, that narrows it down right there a little bit. Now I can't do a whole ton, but if I gave just this set of markings and said, all right, I got diagonals that are bisecting opposite angles and are perpendicular, that narrows it down to a rhombus. And then I look, is there enough information to say this has to be a square? And the answer would be actually yes, because what do I know about each of the big angles? Well, it's an arc and an arc, arc and an arc, arc and an arc, arc and an arc. That means each one of the four big interior angles of the quadrilateral have to be the same, which narrows it down to, oh, wait a minute, those have to be 90 degrees. Okay, and there's only one figure where you've got 90s and the diagonals are perpendicular. It's got to be a got to be a square, because we said that's not true for a rectangle. I don't have that right angle. So that's just a quick look. I guess I got off on a little tangent there as far as showing something's a square, but this one, because there's so much that we know about it, can kind of be tricky as far as showing something or proving something's a square. Okay, so that's the notes. Let's take a look. There's some different just applications on where I would ask you to maybe use this. So obviously, numbers, side lengths, angle measures would be something that I could ask you to find. So we could do this with any one of these three new figures: rectangle, square, rhombus. I guess we're kind of just picking out a rhombus here. So I look at it and say, all right, find the measures of the numbered angles in rhombus ABCD. So obviously, markings wise, we don't know it's a rhombus. Like just looking at the picture wouldn't help. So obviously, this information is helpful. It tells us it's a rhombus. So then I know all that stuff's true that we just got done talking about. So hopefully, it's fresh in our heads here. It's asking us for what is the measure of angle 1, what is the measure of angle 2, it's the measure of angle 3, and the measure of angle 4. So, when I look at this, I see, as soon as I see rhombus, I see, oh, you know what I know about those diagonals? They're perpendicular. All right, that was one of the properties we just mentioned. So angle 1 has to have a measure of 90 degrees. Okay, so on my picture, if maybe it helps, I put a little 90 there. Let's see, what else do I know about a rhombus? I know opposite sides are all four sides are congruent. It doesn't really help me here because we're not really talking about side length. It's all angle measures. The second property about its diagonals was that it was an angle bisector. So that if this is 61 here, this also has to be 61. And then we said, you know what? Because it's a parallelogram, opposite angles have to be completely congruent. So 61 and 61 here and here as well. I think I get 2 and 3 done with really without any work. It's just knowing those properties. Okay. Last one, I think I might have to do some like a little number crunch here. So we are looking for 4. Don't forget some of those properties from previous lessons and chapters that in the end, if I kind of blow up that triangle right there, I got a triangle where I've got 90, I've got 61, and we're looking for this over here. So if I go 180 minus 90 minus 61, what do we end up with? 29. I don't have a calculator in front of me. So I think that's where that works out to 29 degrees for that. So that one came more from not really a property of a rhombus. I applied them to get this 90 and the 61, but then the 4 just came from old school triangle interior angles adding up to 180 degrees. And so that one's a little bit different. All right, so there's just an example with a rhombus. Could be a rectangle, some of those properties. Square as well. Okay. A little bit different here. I like this one. Still, I guess, picking on rhombus, but it could also be, again, square, rectangle. So it tells us, it's asking us for any rhombus RSTV, decide whether, not whether it's true or false, but decide whether the statement is always true or sometimes true. So basically, this is true. These are going to be true at some point. The question is whether it's always true or sometimes true. So I'm asking you to sketch rhombus RSTV. So that should hopefully be just, let's try to make a picture that looks to be all about the same length. Sure. And then it really doesn't matter where I start. I usually just start upper left and go clockwise. Okay, so there we go. There's my any rhombus RSTV. And for each statement, is it sometimes true or always true? So let's take a look at this first one. When, in what situation would angle S be congruent to angle V? Does that have to be true? Is that sometimes true? What do we think? So I would say that always has to be true. So maybe there's not really a ton of room to write. So how would I explain this? It says draw a sketch and explain your reasoning. So I'm going to say that's always true. But why? So I think we need to say something about a rhombus is a parallelogram. Whoops, parallelogram. By definition, like we don't have to say that. Like that's how we define a rhombus. A rhombus is a certain type of parallelogram. So this really just goes back to properties of parallelograms, where we said in lesson 7.2 that opposite angles are always congruent in parallelograms. All right, so I am asking for a little bit more. Like you're not going to say always and just have like a one-word answer for something like that. This is your chance really to kind of show what you know. Hey, rhombus parallelogram, opposite angles are always congruent in parallelograms. That's why that always has to be true. Okay, so a little bit more writing, get closer to like a full sentence type of thing there. Although I'm still like, let's use the abbreviations that we always use. So there we go. Let's look at B then. It's asking about angle T and angle V again. Okay. So when I look at it, I see, well, that doesn't look like that's true, at least on my particular picture. So when would it be possible for consecutive angles right next to each other, right, to be exactly the same? Well, there's only one measure that happens for, and that would be 90 degrees. And then you say, well, 90 degrees, wait a minute, hold on. What happens when this is 90 degrees and this is 90 degrees in a rhombus? Opposite angles we just talked about would have to be congruent. Well, that would have to be 90. That would have to be 90. It's equilateral. So what type of figure are we actually talking about? We're talking about a square. So what I would say for something like this for part B, when would this be true? Just sometimes. In really only one specific case. A really, nice way to say this would be the only time, I'm not going to write the whole thing out because I don't think we have to. This is sometimes true. Only when the rhombus, only when the rhombus becomes a square. Let's see if that makes sense. Like, what do you mean? When does the rhombus become a square? Well, just picture this kind of these sides rotating, or just pivoting closer and closer. These sides are spinning closer and closer to perpendicular. And as soon as we're rhombus, 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 and as soon as I get perpendicular here, we stop calling it a rhombus and say square. But then once if we pass that perpendicular mark, we just keep going and say, all right, we're back to rhombus. So remember, a square is a rhombus. A square is a rectangle. It's just a very specific type of rhombus. It's a very specific type of rectangle. Okay, so there's two just examples of how I might justify something using our new properties. All right, last one. So we've seen some stuff like this based on the marking. So it's asking us to classify the quadrilateral as specifically as possible, and same thing, explain. So we kind of looked at this one, I think, already as far as some of the notes, but let's go just one at a time here. So for part A here, basically I got 4 options. Do I have enough there to say what's the most vague, what's the most broad? A parallelogram. So I think, I'm just kind of taking you through my logic. When I look at this, I see opposite angles congruent. So that automatically narrows it down to a parallelogram. So at minimum, I would say parallelogram. And I'm just kind of looking, is there enough here to extend this and say, well, is it one of these 3 specific types? Is there enough here to say it's a square? No, actually, I'd say there's enough to say it's not a square, right? Because we're marked as different angle measures. And the same goes for a rectangle. So square and rectangle are off the table because I know it's not equiangular. So that just leaves rhombus, and I got to decide, do I have enough here to say it's a rhombus? And actually, I would say, yes, we do. You say, what? What about these other sides here? You don't know these are the same. I think we do, right? So going back to the beginning, that, hey, opposite angles congruent. Right now, I know for sure it's a parallelogram. Once we know it's a parallelogram, what has to be true about it? Well, opposite sides have to be congruent. So if this has a single tick mark, this has to have a single tick mark. If this has a single tick mark, this has to have a single tick mark. So I'm able to add a little bit in that case. I wouldn't always be able to do that, but in this, because we justified that it was a parallelogram, we were able to move those markings around a little bit. So yeah, absolutely, we should say rhombus for this one. So it got to be a rhombus. My explanation is basically, let's try to summarize it and be kind of concise there and say, how about this? So opposite angles guarantee parallelogram. Opposite angles, we should probably say opposite angles congruent, guarantee that this figure has to be a parallelogram. Opposites, so opposite sides, must be congruent then. Therefore, equal, therefore equilateral. How about we say that? Drop a vocab word there. Equilateral guarantees rhombus. Oh, look at all that writing. We can do it. All right. B, like I said, I think we talked about this a little bit. Actually, it's slightly different because we're losing a marking. If we go back to, I think I erased it all. Um, but, I look here, obviously four-sided figure. I see some diagonals. What am I seeing here? I'm seeing, well, there's two things stand out to me. It doesn't necessarily matter the order. If we want to go big picture, I see this whole angle right here has an arc and an arc. This angle here has an arc and an arc, arc and an arc, arc and an arc. So I see that as the four big angles are completely identical. So that right there narrows it down to, well, these both have to be right, or I'm not both, all four of these have to be right angles. So it's kind of a weird way to mark it, right? Like, why wouldn't you just show the right angle? And, well, maybe we should have, but so that right there tells me that those are all right angles. So right now I'm already narrowed down to this has got to be a rectangle, has to be at minimum. It's like a minimum, got to be a rectangle. And then I'm going to ask myself, is there enough here? Let's take these out of there. Is there enough to say, you know what? Yeah, I can take this a step further and say this has got to be a square. So those are the two that I'm trying to decide now between. And if we look, I don't know if I can take that out of there or not. Kind of wanted to go back to where we started, that angle bisector. Well, that's true for a rhombus, right? That's not true for a rectangle. So it's like rectangles off the table, and you wait a minute, are we switching gears and calling this a rhombus? And you're saying, no, it's not a rhombus. We already narrowed it down to square or rectangle because of his 90, 90, 90, 90. But the fact that we've got angle bisectors going on, which we said was true for a rhombus, which is also true for a square, this has got to be a square. So look at that minimal amount of marking going on there. Just almost like a step back and be like, what? Like, really? That has to be a square? Notice we're not able to just automatically go, oh, you know what? I'm going to throw some tick marks on the side here and throw some perpendicular here. I could, now that we've established and we've kind of talked through that it's got to be a square. But before, I'd be really careful there that you just don't see a picture and say, you know what? Why don't we just start doing some of this stuff? And like, that's not how I would start that problem. I really have to go with what I see. Okay, so let's how do we justify this? Well, let's go in the order we mentioned it. So it's got to be a square. Markings indicate, let's just say indicated as equiangular. Hope you can read that, equiangular. So that narrows it down to square or rectangle. Let's just abbreviate. And this is basically what we talked through. So it's got to be a square or rectangle because it's indicated as equiangular. Angle bisectors, or let's just say bisecting op angles, guarantees square. And if you wanted to say, well, what do you mean it guarantees? Because that's not true for a rectangle. And it is true for a square. So it's almost like a process of elimination type of thing. So I'm looking at those properties there, and yeah, when you take a step back, yeah, I just be careful. Again, your explanation should be somewhat detailed there as far as how do we know what's true, what's not. All right. This last slide I have here is there's not really anything to like. Well, it's maybe worth adding the flow chart here as long as we kind of understand how it works. So it's basically saying, kind of the at the very top of this hierarchy is parallelograms. And within that parallelogram family, basically, we've got kind of two specific branches. There's the rhombus family, where we know angle bisectors on the diagonals. We know diagonals are perpendicular. And then the other family would be rectangles, where we know right angles, diagonals are congruent. And when I take those two and bring those together, I get my square. So basically, every property trickles down. these are kind of on the same level. So there's no transfer from rectangle properties to rhombus or vice versa. And then they all get put together in our square property. So I think that's what we talked about as far as, everything kind of trickling down to square. And then it also works this way too, where membership flows upward, where is a square a rectangle? Yeah, it is. A square is a specific type of rectangle. A square is a specific type of rhombus. Okay. Is a rhombus a parallelogram? Yeah, absolutely. Is a rectangle a parallelogram? Yep. Is a square a parallelogram? Yep. If I can connect it kind of going up the chain here, that's true. Is a rhombus a rectangle? And there the answer is no, because they're, like I said, they're kind of on that same level. There's no direct tie from rhombus to rectangle. So these are not, there's no overlap between rhombus and rectangle. All right. All right. So I think it's pretty good. I mean, obviously, we just kind of had the one big goal at the start there, identify and apply properties of parallelograms that have all sides and or all angles congruent. So the and would be the square, but if we have one or the other, we're talking either rhombus or rectangle. And we looked at a couple of different ways that I could just ask you to show me that you know some of those properties. So I think that's it. Pretty good lesson there, 7.4. Let's wrap it, and I'll see you in future lessons.